Hello children, how you are all? I hope you all are doing great. So let us continue with our chapter Physical and Chemical Changes. Children, let us look at another definition of chemical change, that is a process used to rearrange the substances to form new substances with different properties. To understand it, let us take an example. During burning of magnesium ribbon, this magnesium atom reacts with oxygen gas. As you all know, oxygen gas exists as O2, so that's why there are two atoms, 1 and 2 of oxygen. During a chemical reaction, this oxygen will go and get combined with magnesium, forming magnesium oxide. Can you see that in product? This is magnesium from here and oxygen from oxygen gas. So, do you agree that in a chemical reaction, substances rearrange themselves to form new substances, as here magnesium and oxygen rearrange themselves to form magnesium oxide. Here the properties of magnesium and magnesium oxide are entirely different. Same, the properties of oxygen gas and magnesium oxide are again entirely different. So the substance which is formed, the new substance, has different properties. Children, you all might have heard rusting of iron. So here we will look how the chemistry of iron changed during rusting. In activity 4, we saw the iron nails getting rusted. Rusting of iron is very common chemical change taking place around us. You all might have seen this rusting in your bicycle or any other iron article. What is rust? Here is the definition of rust. So please look at it carefully. Rust is a reddish brown substance that appears on the surface of iron article when they are exposed to moist air. Moist means containing water and air. The chemical change that occurs during rusting is represented as. So see what happens. We have any iron article. When it comes in contact with water along with oxygen, it forms entirely different product, that is rust. So we all know iron is represented as Fe and water as H2O. So when they combine with oxygen gas, they produce Fe2O3.H2O. The chemical name of rust is hydrated iron oxide. This hydrated means the water molecule is along with iron oxide. So see children, iron oxide in its hydrated form is reddish brown in color. Now let us understand rusting with an activity. Here we'll see what are the conditions necessary for rusting to take place. Let us do an activity to know the conditions necessary for rusting to take place. Activity 11. Aim: to study the conditions necessary for rusting to take place. Materials required: 3 test tubes, 3 clean and shiny iron nails, anhydrous calcium chloride, cork, boiling water, oil, tap water and a test tube stand. Procedure: take 3 test tubes, label them as A, B, C respectively. Now place 1 clean and shiny iron nail in each of the test tubes. In test tube A, put some anhydrous calcium chloride. This anhydrous calcium chloride is a salt. This anhydrous means it doesn't have any water molecule in it. So here in new words you can see the definition of anhydrous. N means there is no, hydrous means water. So it is without water. Children, this anhydrous calcium chloride shows a property that it absorbs all the water present around it. That is, if you put it in a test tube and place a cork on it, it will absorb all the water, that is moisture present in the air, and makes the air dry, which in turn means no moisture is left in test tube A. So let us understand it with a video. Take 4 test tubes and place clean dry iron nail in each of them. In first test tube, add a little distilled water. In second test tube, either you can add tap water or you can add some salt to distilled water and pour it in second test tube. In third test tube, add freshly boiled distilled water which is free from any gas, and above it add a little oil. This layer of oil prevents any air to come in contact with this water. In fourth test tube, add calcium chloride. This anhydrous calcium chloride absorbs all the moisture present in the test tube. We will seal the test tube and place it aside for few days. In first test tube, there was air and water, so rusting took place. In second test tube, air and salty water was there, so we can see the rusting there too. In third test tube, however, there was no air, so no rusting took place. In the fourth test tube, there was no water, so that's why no rusting took place. So here we conclude that air and water both are necessary for rusting to occur. So see children, in one of the test tube we added boiled water. What happens when the water is boiled? All the air which is dissolved in the water is released off when we boil the water. So in boiled water it is free from air, and when we add little oil to this test tube and cork it, we prevent any air to come in contact with water and get dissolved in it. You will find that a layer of oil is formed above the boiled water. This layer of oil does not allow air to come in contact with the iron nail. In test tube C, add ordinary tap water. Instead of tap water, we took distilled water along with salt and cork it. Leave the setup undisturbed for 2-3 days. Observe in which test tube has the iron nail rusted. Observation. It is observed that only the iron nail placed in test tube C has rusted, that is in tap water. Conclusion. Test tube A has no moisture with iron nail. Dry air alone has no effect on iron nail. So we can conclude that water is also necessary for rusting. Air alone cannot rust the iron nail. Test tube B has no air with iron nail. Water, that is moisture, alone has no effect on iron nail. This test tube B has boiled water, so there was no air. So here we conclude that water alone can't rust the iron nail. Test tube C has both air and moisture, that is the test tube which contain tap water. So the iron nail get rusted. Thus, it can be concluded that both air and moisture are necessary for rusting to take place. Children, you know that rusting of iron is a chemical change and hence it is irreversible. Now we will see few methods to prevent rusting. From activity 11, we conclude that both air and moisture means the water content present in air, are needed for rusting. If we prevent iron article from coming in contact with either air or water or both, they will not get rusted. The method used to prevent rusting are as follows. So our first method is coating an iron article with paint. Applying coat of paint on iron articles prevent them from coming in contact with air and moisture. So, if this is our iron article and if we place or if we coat it with a paint, this paint will not allow air and moisture to come in contact with iron article, thus prevent rusting. These coats are applied regularly on iron articles. So, our first point is coating an iron article with paint. Second method, coating an iron article with grease or oil. Applying coats of grease on an iron article cuts off its contact with air and moisture. Again, this coating of grease, it also prevents air and moisture to come in contact with the iron article. This prevents the iron article from getting rusted. Let's look at the third method of preventing rusting. Galvanization. It's a new term for you, so let's understand it properly. It is the process of depositing a layer of zinc. Children, please pay attention. Here we put a layer of zinc on iron article. So let's see what happens if this is your iron article and if we put a layer of zinc on it. If we deposit a layer of zinc on it, it will not allow air or water to come in contact with this iron, hence prevent rusting. The coating of zinc does not allow the iron article to come in contact with air and moisture and thus prevent it from getting rusted. See children, this is a normal iron article whereas this is the galvanized one. What we do in galvanization is we dip an iron article in a pool of molten zinc, that is the melted form of zinc. And as we dip this iron article in this molten solution, it acquires a coating of zinc on it. Children, actually zinc is more reactive than iron. That's why it reacts before iron. Or you can say it sacrifices itself before rusting of iron. So it prevents iron from rusting. Let's see the definition of galvanization in new words. Galvanization, process of depositing zinc on iron. Let's move to our next method, alloying. Have you ever noticed that some articles like scissors, blades and utensils do not get rusted at all? What are these made up of? These articles are made up of stainless steel. I hope you all have heard about stainless steel. Actually, stainless steel is a special substance which is made by mixing some carbon and metals like chromium, which is represented as Cr, manganese Mn, and magnesium Mg with iron Fe. So when we add all these things along with carbon, we get stainless steel. Stainless steel is a special substance which is made up of mixing again carbon, metals like chromium, manganese, magnesium, iron. So the process of mixing metals or non-metals is called alloying. So let us understand what is alloying. We have iron which is very prone to rusting. So when we add a little carbon to it, we get steel. The properties of iron and steel are not same. It acquires few new properties. Now if you add few more metals in it like chromium, manganese and magnesium, we will get stainless steel. So here this steel, though it contains iron, will never get rusted because it acquires entirely different properties from that of raw iron. So alloying is a process of mixing metals or non-metals, that is we can mix metal with metal or metals with non-metal to get entirely different properties, and this process is called alloying. The new substance formed by mixing is called an alloy. So, stainless steel is an alloy of iron. Alloying prevents rusting. As you can see, if we get alloy of iron, that is stainless steel, it will never get rusted and hence prevents rusting. Now look at the definition of rusting. Formation of red or orange coating on the surface of iron when exposed to air and moisture. I hope you all now can define rusting. It's a formation of red or orange coat on the surface of iron article when the iron article is exposed to air and moisture. See, we are using and here, not or. That means both of them, air and moisture, both are necessary for rusting to take place. Let's look at crystallization. It's a process of forming crystals from a solution, which we will see in next video. So crystallization will be discussed in your next video. Okay children, let's continue with our favorite part, that is discussing the questions. Your question is, name a method which can prevent rusting. I hope you all can give answer to this question. And the answer is galvanization. You can go with alloying also, or painting and greasing. Next question. What do you understand by rust? Represent the chemical change that occurs during rusting. So you all know rusting is a reddish brown substance that appears on the iron article when they come in contact with air and moisture. Chemically it can be represented as iron, Fe, when reacts with water, H2O, and oxygen, O2, it produces Fe2O3.H2O, that is hydrated iron oxide. Let's move on to our next question. What is stainless steel? The stainless steel is an alloy of iron. So stainless steel is an alloy of iron which is mixed with some carbon, chrome, manganese and magnesium. Question number 13. Define alloying. So you all know the process of mixing metals or non-metals is called alloying. Here metals can be mixed with metals or metals can be mixed with non-metals. Our next question is, how does galvanizing prevents rusting? Answer to this is, the coating of zinc on iron article, that is galvanization, does not allow the iron article to come in contact with air and moisture, thus prevent rusting. Okay children, now next question. Look at the diagram and answer the following question. So see, in the first test tube A, they are reacting vinegar and baking soda. So the formula of vinegar, actually vinegar is a solution, 5 to 8% solution of acetic acid. What is acetic acid? Acetic acid is CH3COOH. This is the formula of acetic acid. When we add 5 to 8 gram acetic acid in 95 gram water, we call it as vinegar. Okay, so the formula of vinegar will be CH3COOH. When it reacts with baking soda, the formula of baking soda is NaHCO3, that is sodium bicarbonate or sodium hydrogen carbonate. So when they both reacts, I hope you all know what reaction takes place. So here carbon dioxide will release from here. So one product will be carbon dioxide. Along with carbon dioxide we'll get water from here, and the third product which we get is sodium salt of acetate ion, that is CH3COONA. Okay, so here we should not bother about all these things. The main focus for this standard is carbon dioxide. So let us look at the first question. A. Which gas is released in test tube A and B? So you all know in test tube A, the gas released is carbon dioxide, which you can see here. Let's see what happens in test tube B. In test tube B, zinc is reacting with dilute hydrochloric acid. I hope you all can work out the reaction. This is zinc when reacts with dilute HCl. So we will get very good zinc chloride plus H2 gas. So the gas released in test tube B will be H2 gas. Okay, B part. What test will you perform to identify these gases? So you all know, to test carbon dioxide, we have to pass it through lime water, and we'll see that lime water turns milky due to the formation of an insoluble salt. Okay. For testing H2, what we do, we bring a burning matchstick near to the gas which is being released, and it will produce pop sound. That is, it will burn with a pop sound. I hope this is clear to you. Children, you have to note down all these questions in your notebook from the PDF provided to you. I hope you all enjoyed the session. So keep smiling, keep learning, and have a wonderful day.